You know. Okay, Assalamualaikum and a very good afternoon to everyone. My name is Muhammad Zahid Barom, and as for today, I would like to present my project which entitled The Evaluation of Sediment Toxicity from Tumpat Lagoon on the Survival of Chironomus Kensis. This is the further details as mentioned by my supervisor just now. Okay, what is toxicity testing? Toxicity testing is a standard procedure to predict amount of chemicals according to their effects on tested organism. While for the sediment toxicity testing is established to investigate the ecological and biological changes in a test organism. So, the test organism used in my experiment was chironomid. Why? Because chironomid is well known as a bioindicator to detect pollution in sediments such as organic or inorganic and heavy metals. So basically, this is the life cycle of chironomids. And chironomids spend its larval stage in sediments. Injections of contaminants occur during the uptake of food from the sediments, and it is called as the deposit feeders. So the indicators that I have looked up to in my experiment were such as the survivability, the mortality, and the sex ratio. The sex ratio is also one of the good indicators that we can look up to, as the toxicant present will affect the sex ratio of the chironomous species, as males are more tolerant to toxicants compared to females. Okay, here are my objectives. First is to determine the survival of chironomous kensis exposed to 100% of volume of natural sediment from Tumpat Lagoon. Second is to determine the survival of chironomous kensis exposed to 50% volume of Tumpat Lagoon mixed with 50% volume of control sediments. Okay, my study area is located in Tumpat Lagoon, Kelantan, where near the border between Malaysia and Thailand, with a population of 143,793 people according to the Department of Statistics. So the source of income in this area are mainly come from fishing and aquaculture activities. So the reason why I choose Tumpat Lagoon as my study area is mainly because the presence of poisonous blood cockle, which was reported in 2015. So the poisonous blood cockle were influenced by the domestic waste pollution done by the communities. These are some reports which were reported back in 2017 and 2016 regarding to the improper waste, domestic waste dumping by the communities of the villages. And also, Tumpat was also reported with the occurrence of harmful algae bloom (HABs) back in 2001 and have affected 6% in the area. And somehow, this proved that my study area is very much polluted and cause severe negative impacts to animals and humans. So this is my methodology. The first step was the sediments collection, followed with the preparation of chironomous kensis, control and natural sediment, and lastly is the first and second toxicity testing. Okay. The controlled sediment, natural sediments collection. The water parameters were recorded by using hydraulic quantum multiprometer. The water parameter was such as pH, DO, salinity, and temperature. The sediments were collected using Ponagraph, and lastly, the sediments were dried using freeze dryer and sieved through 250 micron-meter mesh sieve. Okay, this is how I prepare or cultured my chironomous kensis. This is the exposure scheme. So, first, 24 larval instar were placed in each tank A, B, and C. So, the aeration was provided for each tank. Food tetrabit was given in 2-day interval, and lastly, water was changed once in 3 days. These steps were referred to United States Environmental Protection Agency chironomic guideline with slight modification. So first, 4 instar larvae were cultured till they emerge to become male and female. So they will undergo the process of fertilization, and female will produce egg mass. So the egg mass will hatch and in a week and become the first instar larvae and then second instar larvae. So the second instar larvae were used in my experiment because of its sensitivity towards pollutant present in the sediments. Okay, this is how I prepare my control sediments. First, the sediment was taken in the pristine coastal area, then weighed 3 grams for 3 replicates, and soaked with 10% nitric acid and left overnight, and then rinse with deionized water 2 to 3 times, and then again soak with 6% artificial salt water, and lastly dry at 50 degrees Celsius for 3 days. Okay, these same procedures were applied in the second toxicity test. Okay, for the preparation of natural sediments, the natural sediments was taken in Tumpat Lagoon, again 3 gram natural sediments were weighed and for 3 replicates each, and then soaked with 6% artificial salt water, and lastly dried at 50 degrees Celsius for 3 days. The same procedures were also applied in the second toxicity test. Okay, this is the illustration on how first and second toxicity testing were conducted. So the first toxicity testing used 100% of natural sediments from Tumpak Lagoon, and the second toxicity testing is basically used 50% of control and mixed with 50% of natural sediment. If let's say that the sediment is 3 gram, then 1.5 from the control sediments and another 1.5 gram was from the natural sediments. Okay, these steps are for the toxicity test. Okay, first, the 10 chironomous cases were transferred into 3 replicate glass jars, including control and natural sediments, and then temperature, salinity, pH, and dissolved oxygen were recorded. Chironomous cases was acclimatized for 24 hours. Survivability, mortality, and sex ratio of larvae were recorded. So basically, this step will also refer to EPA with slight modification. Okay, these are the picture of how I'll conduct first and second toxicity tests. Okay, for the exposure scheme, this first, second install larvae were used because of its sensitivity. 3 replicates for each station, including control. Aeration provided for each replicate. Food tetrabits was given once in 2 days. Water changed 1 in 3 days, and observations such as survivability, mortality, and sex ratio were done on daily basis. This exposure scheme also was applied in the second toxicity test. Okay, for the results and discussion, this is data taken for physical parameters water for both tests. So according to the EPA guidelines, the temperature should be kept 20 to 22 degrees Celsius. The dissolved oxygen concentration should be maintained above 60%. So we can say that my physical parameters of water were in optimum levels. So it does not affect the survivability of test organisms. It should be the contaminants itself in the sediments that will affect my survivability of the larvae. Okay, this is my result of the discussion. For the survivability rate in toxicity test 1, as you can see from the graph, control has the highest percentage of surviving larvae, which was recorded 96% for both tests. Okay. In test 1, station 3 and station 4 were recorded the lowest surviving larvae with 33% and 23%. So there could be some contaminants in the sediments that have influenced the survivability of the larvae. And then, as stated by Al-Shami, the contaminated sediments influence higher mortality of chironomous cases due to high concentration of heavy metal. So there could be some concentration of heavy metal that have influenced the survivability of my larvae. Okay, next. In test 2, the surviving larvae in station 3, 4, and 5 have increased to 63%, 67%, and 100%. So the toxic chemicals in the sediment could possibly have decreased due to the mixing of natural and controlled sediments. Okay, moving on to the mortality rate in toxicity test 1 and 2. So basically, the mortality rate data is inversely proportional to the data of my survivability rate. So in control, the percentage mortality was only 4% for both tests, and then the percentage of mortality of station 3 and 4 in test 1 were recorded higher, 67 and 77% accordingly. So the mortality rate in test 2 for station 3 and 4 have decreased to 37% and 33%. So there could be an effective dilution by using control sediments could be a remedy to the polluted sediments. Okay, for the emergence rate of chironomous cases in toxicity test 1, as you can see from the graph, station 2 has the fastest emergence rate, which was recorded in day 7, and then control was recorded in day 8, and the significant delay in emergence rate was recorded in station 5 and station 3. So, certain toxic chemicals associated with total organic carbon induce the significant delay in emergence rate. So basically, emergence rate in this means the emergence from the larvae to become an adult of the chironomous cases. So basically, control, station 1, station 2, and station 5 have achieved above 70% of emergence rate, except for station 3 and station 4, which have achieved below 40% of emergence rate. Okay, moving on to the emergence rate of chironomous cases in toxicity test 2. As you can see, the the emergence rate of all stations have improved in toxicity test 2 in the mixing of controlled and natural sediments. And then, all stations achieve overall above 60% of emergence rate in mixed controlled and natural sediments. As you can see, the station 3 and station 4 also have improved in terms of emergence rate and the survivability. Okay, the sediment dilution method has lowered the concentration of toxic chemicals as stated by Swigel, and then increased the emergence rate of test organisms in station 3 and station 4. So, for the number of mates by sex in toxicity test 1, in test 1, control station 2, station 5 have the highest production of female compared to male, while in test 2, control station 2, 4 and 5 have also the highest production of female compared to male. But in station 3, the production of male is higher compared to female. So there could be something in station 3 that have influenced the sex ratio of the Carimus cases in the station 3. So, as stated by Goikub, females appear less in a toxic condition because female needs a suitable energetic reserve for the production of egg masses. Okay, as for the conclusion, the lower survivability rates in test 1 were recorded in station 3 and